This is Jim Shaw from Crystal Group, and a while back we talked about different chips that are currently present on motherboards, specifically on a lot of the server class motherboards. And today we're taking a little bit deeper dive into FPGAs, which is another chip that we frequently see in our industry. It's becoming a need and a capability in our industry, and I'd like to introduce Will Byers. Will is an FPGA engineer, electrical engineer, and Will is part of the Advanced Program Pursuits team here at Crystal Group. And Will, welcome to this podcast.
Thanks, good to be here.
Hey, Will, what is an FPGA and what kind of advantages does it provide over traditional technologies?
First, FPGA, it's an acronym for Field Programmable Gate Array. And essentially what that chip allows you to do is, traditionally you have a chip that it's only one function, right? You make the chip and it only does one thing. FPGAs are set up to be programmable. So you can take that functionality and it has a bunch of resource blocks inside of it that you can connect in different ways and change at the pins what the functionality is of that chip. So the advantages of that are it really makes your hardware a lot more flexible. So if you wanted to have compute in there and you wanted to be able to replace what that compute is doing really easily, you could do that with an FPGA. You would have your couple of blocks, and when you want it to do one thing, you would load it with one image. When you want it to do another, you load it with the other image. And because of that, it allows you to do especially in the world of acceleration. We talk about acceleration a lot, specifically in regards to like cryptography or other, sometimes with graphics you can do it too. So it kind of allows you to take advantage of what the GPU does, but on a more general compute scale versus just graphics only.
Interesting. Okay, so with an FPGA you get really flexibility.
Mm-hmm.
So rather than having an IC that does one function, you're able to reprogram or change the function of the FPGA so it could do different kinds of encoding, decoding, video processing. The number of applications are kind of endless, really, when you kind of think about that. But you get to do that all from a single chunk of silicon that is flexible.
Yep. And one thing to mention too is compared to ASICs, which are your chips that don't change functionality, an FPGA is going to be a little bit more costly to put on a board as far as the component goes. But overall, it's a lot cheaper than actually going through a foundry and spending potentially millions of dollars to spin an ASIC to put on the board for a specific compute application.
Hey, Will, who are the big players in the FPGA industry that are manufacturers of these devices?
So the two big ones right now are Intel Programmable Solutions, which was formerly Altera, and Xilinx, which is now under AMD. So those are the two big names. A couple smaller ones are Lattice and Microsemi, but for sure Xilinx and Intel are the big names in the industry right now.
Okay, good. Hey, what does it take to start laying out or using an FPGA in a circuit? What does it take, and how do you actually do that from a practical standpoint?
Yeah. So from a hardware perspective, it's just like any other chip on the board. You have a die that you put down on the PCB and you route your signals to it. From a programming perspective, how do we achieve that reprogrammability? You're going to use what's called a hardware definition language, or HDL. Some examples of that would be VHDL or Verilog or System Verilog. So essentially what you're doing is you're describing what you want the hardware inside that FPGA to do, and then you will take it to, in the case of Intel, Quartus Prime, or in the case of Xilinx, Vivado, and you'll give it your code. It'll run what's called synthesis and implementation, which basically takes all the code that you gave it and turns it into a form that the chip can understand, and then you load that form onto the FPGA to run.
Okay, we talked about a couple of different applications. Can you expound on that, specifically, what these things are used for, typically in our industry?
Okay, so I touched on acceleration a little bit earlier. So one of the most common areas to accelerate is cryptography. Just by nature of what it is, it's a lot of computation, it's a lot of compute resources needed. So burdening your CPU with that isn't always appealing or acceptable. So if you implement a cryptographic algorithm in the FPGA, you can send data to it, and then the FPGA can do it faster, and your CPU is not doing it, so you can do other stuff while you're doing the compute. So that parallelization is a big thing in the accelerate area. Beyond acceleration, you can do a lot of media conversion. So from, you can do some really crazy stuff if you wanted to. You could go from, let's just throw something out there. If you want to do USB over fiber, you could, technically, as long as you have the know-how to do it. So it kind of removes the limits on, hey, I only have this IC which does USB to SATA, for example, or PCIe to fiber. You can mix and match how you want to do that. And then on top of that, we mentioned a little bit video processing. Due to the highly parallel nature of FPGAs, you can get some, video processing. If, say, again, you don't want to load your GPU up with all the graphics processing, you can do some of that in the FPGA as well. So graphics pre-processing or inline processing, however you want to do that.
Yeah, and I understand that you can also do software-defined radios.
Yeah.
With FPGAs.
Yep. So that's a really common use case in the industry. We don't do that here at Crystal, but it is a very common thing for, especially like the data link layer, the modem layer, to be implemented with an FPGA.
Hey, well, when does it make sense to implement an FPGA design versus maybe a more traditional or available COTS architecture? When does that make sense?
Well, so right now the industry is kind of interesting because they are coming out with COTS solutions that have FPGAs that you have the resources on the FPGA are already pulled out to defined interfaces, and then it's up to the end user to load the FPGA with what they want it to do. But as far as we'll use the terms application specific, and then FPGA is the other side of that. Mm-hmm. So application specific hardware is going to be, it does one thing, that's what it does, you can't change that. So by introducing the FPGA into that, now we can say, okay, we have this hardware, COTS, if we want this functionality COTS, we're limited to what the suppliers have, right? Mm-hmm. So now by looking at doing a custom FPGA solution, we can design exactly what the customer wants into that. And then you can also leverage the COTS FPGA solutions that are out there to help prototype or help speed the development while you wait for your custom FPGA solution.
What advantages does this FPGA capability have for Crystal Group?
So for Crystal Group specifically, what utilizing FPGAs will allow us to do is to highly customize our compute solutions for our customer, as well as adapt quickly when those compute requirements change. So instead of having to respin a whole board to change what's going on in the customer system, we can just go change some code and reload it on their FPGA-based hardware. So really it's about adding compute capabilities, so things that they don't necessarily see or aren't common, and we can do it easily. That flexibility is a big important part of it. We're not locking people into, hey, here's just one solution, and then you need an entirely different solution to do something similar but not quite the same.
So it kind of sounds like, Will, that if your chip never changes, you have lots of volume, and the functionality requirements never change, an ASIC is the way to go.
Yes.
But if there's an FPGA, it gives you flexibility. You have the acceleration that is so critically important in the industry today. And you really have full performance IC type of technology that we can actually dictate the interface, the ins and the outs, to make the chip function as we so desire.
Yep.
Perfect. Well, Will, is there anything that I've not asked you that you'd like to comment on relative to FPGAs?
No, other than we're really excited to be getting into this and start seeing what we can do with it. It's a cool technology that we get to use. So,
all right. Well, hey, thanks for spending some time with us today, Will, on this podcast. Appreciate it. And you listeners out there, if you have any questions, please contact us at crystalrugged.com.